In this part of the tutorial, we're going to introduce float and double variables in iOS. So we're going to do this by declaring and initializing some floats and doubles, and then we're going to give them the values as well as changing them later on in the code. So we'll use real-world examples of interest and perform some operations with doubles, as well as discuss the difference between ints, floats, and doubles. So this part of the tutorial is going to deal with floats and doubles. Now there are subtle differences between the two. They're both ways to represent numbers with decimal places, but again there are minute differences that I'll explain right now. So whereas integers could only represent numbers without decimal places, both floats and doubles can have decimals. The difference being that a float of type float, let's call this number 1, can have 7 digits, so it will represent decimal places up to 7 digits. For example, if we had the number 100 and a bunch of decimal places, so let's just type in some random numbers, it would only display 7 digits. That would be these 4. It wouldn't display these last 5. And just to prove that to you, I'm going to print it out in just a minute. Another thing with floats is we have to include the f at the end. Now Xamarin automatically interprets decimal places as being doubles. So if we don't include this f, then we get compilation errors because it thinks that this number should be a double, but we're calling it a float. Now I'll show you what a double looks like. Let's just call this double. Let's just call this number 2, and it can just be 5 and a bunch of 5s after it. So let's see how many 5s. Just printing out a bunch of 5s, and we'll see how many it actually interprets. So notice down here a little different from the previous 2 videos. We have a couple of labels this time. All I've done is I've gone to main storyboard and I've added in another label below the first one. And that's because I want to print out these 2 numbers, one on top of the other, just to prove a point. So we have, this is going to be number 1, and again we're going to have to convert it to a string, and we'll do the same with number 2, to string, and we'll just have them printed out. So let's go ahead and run this, run it with the iPhone 5S, and we'll wait for it to load up here. Here we go. Alright, so again notice how only 7 digits were printed out, and this is what a float does. It prints out only 7 digits, whereas what the double does is it will print out 14 decimal places. So it doesn't matter how many numbers we have, or rather how many digits we have to the left of the decimal. We could change this to, this crazy number here. It doesn't matter, it will still display 14 decimal places. However, again, a float will only display 7 digits. So this is the main difference between the two. The other difference being that in Xamarin Studio, a lot of the built-in math functions only deal with doubles rather than with floats. So if we want to use those with floats, we have to do what we would call typecasting. However, that's another topic for another video. So again, decimal places here, 7 digits, and here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 decimal places. And that will always be that precise when it can be. If we don't provide 14 decimal places, that's fine. And in fact, we don't have to provide any decimal places at all. We could just print out a number 5. I'll show you up here. And I'll also demonstrate what will happen if we include a bunch more digits in front of the decimal. So let's go ahead and run this. So here I've just put a bunch more digits in front of the decimal to see if we still get 7 digits total being printed out. And here we still get a 5 with no decimals, so doubles can be decimals or non-decimals. And here we get scientific notation, so it tries to maintain those 7 digits, 1, 2, 3, 4, 5, 6, 7, but it's converted to scientific notation to keep the 7 digits. Now let me show you an example of some of the arithmetic that you could perform with doubles. So I'll just get rid of this because we'll no longer need it. Let's call this something a little more appropriate. So let's say this is interest. And let's say we have this being 3 point, however many threes that is, percent interest. And we're going to first display the interest. We're going to say this one's just interest to string. And then this one's going to display something different. What we're going to do is we're going to call system math, and we're going to call the power function. Now we call system.math because this is a built-in function, and we have to do that every time we use a built-in function. I'm going to just go ahead and enter a couple of doubles. This power function takes in 2 doubles, and it will basically raise the first double to the power of the second double. It's like an exponential function. So we'll just have, let's say, $500, and we'll raise it. In fact, here we go, here's some information here. So it returns a specified number raised to a specified power, and it takes in 2 doubles, not floats. So let's say this raised to the power of interest, and we're going to assign this the value of, we're going to call this, let's call this total money. Just something simple. And this one will print out total money. Cool, let's go ahead and run this. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, not as precise as we could be. So we have, first of all, the double being printed out here, and then we have the result of our function, which is a huge number because it is 500 raised to this power, which should be a large number. Alright, this is floats and doubles, and this is the difference between the two. So again, floats 7 decimal places total, and that includes numbers to the left of the decimal point, whereas doubles can be precise up to 14 decimal places. In this part of the tutorial, I introduced floats and doubles. So these are both ways to represent decimal numbers with subtle differences. So doubles are always precise to 14 digits if necessary, but if there's a number with fewer digits, it won't display all 14. However, floats are only precise to 7 digits. So regardless of where the decimal place is, the maximum number of digits a float will display is 7. So I use the example of interest and the built-in power function to show that certain functions only accept doubles rather than floats. Although we'll not always need the precision of 14 decimal places, so a float might be more appropriate, again, certain functions don't like floats, so require casting. In this case, it might be more useful just to stick with a double. So by now you should be able to tell the difference between the 3 number types. So the number types being integers, floats, and doubles. And you should be able to tell when to use each one.